Stan Jabalisco here, proprietor and operator of amateur radio station W1, GV, Whiskey 1, Good Vibrations. Occasionally, I get asked a question about wire, about the choice of wire for wire antennas. And the answer to that question varies depending on what type of antenna, or more particularly, what part of an antenna you want to talk about. Generally speaking, if you have a wire antenna, either vertical or horizontal, you do not want that antenna to stretch ever, whether it be a random wire or whether it be cut to a specific length. Say you want to make a 40-meter dipole and you want to cut each leg of the dipole to, let's just say, 33 feet long. The overall length of the antenna then being 66 feet, or approximately 20 meters. That would be a half-wavelength dipole. Now, it doesn't matter whether the supports are trees or poles or towers or buildings or whatever. You don't want that wire to stretch over time. Now, when you go into a hardware store, any hardware store, you can find good electrical wire for house wiring, down to usually about 12 gauge, sometimes even 10 gauge, sometimes even 8 gauge. It's soft-drawn copper wire, and it's an excellent conductor. But you do not want to use that for an antenna, for the radiating portion of a ham radio antenna, because over time it will stretch, particularly if the supports are in any way unstable, such as trees, and or as snow and ice accumulate on them, which in most parts of the United States of amateur radio will occasionally occur. As the wind blows against it, over time that wire will get longer and the antenna will tend to sag more and more. You want to use a wire called Copper-Clad steel. Now, that is not available in some hardware stores, or even most hardware stores. You may have to order that online, but I would recommend using 10 gauge or 12 gauge copper-clad steel wire for the radiating portions of all wire antennas. If you're feeding the antenna with coaxial cable, of course, you don't need to worry about the wire used for that. If you're going to feed it with a ladder line, a slack ladder line, that probably should be soft-drawn copper wire, because if it's not under stress, and you don't necessarily want to have the feed line of an antenna under stress. Suppose you string a dipole between two poles and you feed it with ladder line, and the ladder line comes down from the middle of the antenna, which has no support, and sort of hangs slack as it runs into your station. A common arrangement. You don't want to use copper-clad steel wire for a open wire or ladder line type of feed line. The reason for that is because copper-clad wire, you'll find as soon as you get a coil of it, a bundle of it, it tends to want to spring back to its original shape. And if it's slack and you run it for open wire, it's going to be impossible to maintain even spacing between the wires because of this tendency of the wire to bend, unless it's under stress. But for the antenna should be under stress, a certain amount of stress, so that it's straight in the case of a dipole. Now this is all a hypothetical in regards to whether your antenna is straight or not. You may want to zigzag it, but you always want these elements to have straight segments, and you want them to be under tension. Soft drawn copper wire is no good for that, because it will eventually stretch and your antenna will sag. If the antenna is cut to resonance, that will detune the antenna. Even if it's a random antenna and resonance of the antenna element is not so important, you don't want it to sag with time. If the supports are movable, such as trees, which might sway in the wind, or if it's possible that heavy ice may accumulate on the antenna, you can use stretchable material beyond the insulators at the ends of the antenna to where the supports go, like rubber straps or some other such contrivance which will flex and yet allow the some movement of the support while maintaining tautness of the wire. Springs, heavy-duty springs, are quite good for this. The insulators that you use at the ends of the antenna should not be the egg insulator type, but the regular type of insulator with 2 holes at either end and cylindrical in shape, ideally ceramic. You'll probably have to go to QST and order those as well. And they should be as large as you can make them, because if they break, your antenna will fall down. Egg insulators, if they break, your antenna won't fall, but you will have more end capacitance because of the way the wires overlap. Even if you use nylon rope, egg insulators are not a particularly good choice for the ends of an antenna. If that's all you can get, then you must use a non-conductive material such as nylon rope at the ends of the antenna, along with the aforementioned springs or straps to allow for some flexing. But in any case, for the radiating portion of a wire antenna, copper-clad steel is the best choice, in my opinion. You might ask, well, isn't copper a better conductor than steel? And if you use steel for the core of a wire, isn't that going to reduce its conductivity? And the answer is, at DC, direct current, yes. At low frequency alternating current, such as your house wiring, yes. But at radio frequencies, a phenomenon called skin effect causes most of the current to flow towards the outside of the conductor, regardless, so that the inner core, which is made of steel, it won't matter that it doesn't conduct as well. In fact, that's why you often see tubing used, aluminum tubing, for example, for a Yagi or a vertical antenna that's supposed to be rigid. If it were a solid aluminum rod instead, it'd be an awful lot heavier and it would conduct DC an awful lot better, but for radio frequencies it would make very little difference. So these are some tips on wire antennas. I consider wire antennas my specialty even within the antenna regime, the antenna kingdom, the antenna empire. So that's my advice. Consider copper-clad steel for the radiating portion of any wire antenna. Stan Gibilisco, W1GV, signing off, saying 73 and so long, which, regardless of the antenna type, always translates to da-da-da-da-da-da. So long.